Nice. Hey, my name is Darrell. I'm software engineer at Neo4j, team of the GraphQL system. We work on the Neo4j GraphQL Library, which is basically open source library to accept GraphQL queries, and then we convert that into a single site query, execute it against the database in a nutshell. But I'm not really here to talk about products today. I'm going to talk about the validation system in GraphQL, specifically like the SDL validation system, because as we'll find out today, there's some kind of nuances between the two things. And we'll explore how this today. But first, I'm going to play a game. So, let's have this. I will give beautiful. Everyone see it now. It's so nice and lovely. So there's some type definitions here, right? We're going to validate these type definitions. How many problems are there here? Yeah. based on like how many genuine like SQL validation problems are there here? Feel free to shout them out one by one, and then we can talk about them. How many there are? Two. Try again. But
Two, yeah.
at least two. So let's have a look. So we've got a directed definition, right? Foo on field definition. We can see here it's used one type. Problem number one. We have an interface and a type with the same name. This is a bad thing. This is going to be a validation problem, right? There's another one which is really weird. Because they have the same name, it says that these are used with a field, plus number 3. And there should be a fourth, right? Here. The number instead of a string in the So we look at this. So basically, some really simple code here. We have our definitions. I make this into a document node, and then we're going to pass it into the validate SQL function in the GraphQL library, which should validate document node, and then print out the number of errors and what the errors are. If I now run that, we see 3 validations. So there can only be one type named foo. We looked at that one, the weird one, which is a result of the type names, and then finally like a can't use an object. But how about our number in the argument for the directive argument? It doesn't seem quite right. So we'll correct our initial problems, we'll do .C#I for the interface, we'll remove the directive that shouldn't be there. And then, according to GraphQL validation, that should be fine. That's not right. So let's explore that a bit. So if we jump into the stretch, the GraphQL stretch, to the validation section, there's this chapter here about the directive validations. They must be funded, they must be valid locations, they must be unique allocation. Nothing but arguments here. And then we've got the values must be of different type. This sounds promising. But if we look into all of the examples here, this is query. This is a query. Completely unfair from respect to actually just all that family of applied to like validating queries that are coming in and comparing them against us. And you can actually kind of call this, which is hence the title of this talk. It's originally about validation rules, but then actually you run into the reference GraphQL library, you can find all of these specified rules in the library. But there's specified rules and there's specified SDL rules. SDL rules apply to the type definitions, which we saw before. It's a much smaller list you can see, just a very small text. There's not you entry stuff. Any type names, which we saw, unique directive names, known type names. So then our values of correct was here. Specified rules. You cannot use these rules during SQL validation. You have it in the type feature. Must be what you would expect. So it's an interesting one. Yeah, it's an interesting one. So I was hoping for this before using some custom validation tools to overcome these shortcomings. So you can create AST visible functions. This is one of these functions. It has 5 arguments. During like a validation, it's basically saying good job. This is as it can do every single node is in your SQL. So the thing you're on. So let's say we're looking at directives. We'll have a directive validation rule, and it will be the then again, it's one of the more complex things. Index or keep is no parent, so that's what is parent. It's likely to be an array, the typing mistake can be a lot more. It might have time it's going to be an array. So this keep code is an actual array. Then we have path, which is a string. Really should be an object, as we'll see. Refers to path within ancestors. Yeah. So if we
So similar string that you can only do while you're trying to
so let's look at the node keep parent and path first. The node is our directive, and parent is actually all of the directives on that location.
Echo cancel should be off to stereo audio.
Is 1.
I think that's fucking
0, 1, parent. And then, this is an array.
Initial string, then the next entry, then a number, then the next entry, then a number. So definitions 2, fields 0, directives 1. Horrible. And then let's jump into the ancestors, which kind of deserves its own slide, which is, it's an array. So the first entry in the array is the whole document, this entire thing. The next one is, it looks similar, but this is actually an array of all of the definitions. So the directed definition, object definition again. Then the specific object definition that we're looking at. And then the fields within the object definition, and then finally the single field which contains these directives. So document definitions, object definition, field definitions, definitions. So it's single array, single, essentially as you go through. So with all this ammunition, it's a very quick talk, so it's a lot to talk about in a short period of time. I was hoping that we could go through some kind of custom rules here. So what I have, we'll get rid of this import of the GraphQL validate SDL, and we'll change that to one that I have locally. It's basically exactly the same thing. Inside here, we're just basically replicating it. So we're accepting a document AST, then we're using the validate SDL reference, but instead of just passing in a document, we're going to pass in undefined, I forget what the second argument is, a schema to extend. We'll ignore that. And then we're going to pass in some different rules. So we're just going to pass in to start all of the specified SDL rules. This is basically validate SDL as it is. It's basically the same as what we were calling before. But I have added, I've created a new rule called directive argument of correct type rule. And we can jump into here. This is definitely not a live coding exercise. It's, I would say, kind of too complex to write during a small talk like this, but you export a function, it has a context. This context is important because this is how you report errors. So you can see actually if we do encounter an error at some point, we'll do this context.report error, and you pass in a GraphQL error. Then, so yeah, for directives, we have all of these arguments that we discussed before. Then we're going to do some kind of horrendous stuff. Just accept the fact that this is a GraphQL schema now. This is just accepted as a small function that does it. It just builds the AST schema from the document node. I didn't want to go into that during this talk. Then it gets the directive name. It gets the directive definition from the schema. We don't care if there's no directive definition because there's already a rule in the specified rules for that. So we'll just return. Then for each argument, in our node, we're going to go through. We're going to try and find the argument definition. Once again, if it doesn't exist, we don't care. There's another rule for that. We're just going to ignore it. And then finally, we actually kind of turn the argument definition's type into a GraphQL input type, and we turn the kind of AST value into an actual just JavaScript value, and then we try to coerce the input type. So we're essentially just trying to coerce the type from the directive using the type from the definition. As I said, it functions. There's probably a much nicer way of doing this. But then the final argument here is a callback, which is basically saying if you encounter an error whilst trying to coerce this value, this is how I want you to deal with the error. So what we're going to do is, if that happens, we're going to throw an argument, throw an error, expected argument, blah, on directive, blah, to have type, blah, and I received blah. So we've now included that in our rules list, and then we're now running this custom validate SDL instead. So now when I run this, great. So expected argument bar on directive foo to have type string found 647. Success. We have something which probably should be in there in the first place finally working. So great, we can now fix this. Let's just make it a string. And then we can see I have 0 validation errors. So this is good. If I have some time, which I think I do, I have plenty of time, this is good. We can go further. What if we want to start thinking about business logic instead of kind of actual, is it correct? Like, you know, it's always bugged me that we don't have a better location than field definition. I can't say I want this to be only applied to interface fields or object type fields, just field definition, which is just completely unhelpful sometimes. So what if we were to kind of say, actually, foo should only be available in interface fields? I think this is like a fair ask, right? So I created another one earlier, of course, because I'm not doing this right here. I believe I called it foo interface field definition directive rule. And I believe, thankfully, but this one is a lot simpler. So going into our visiting function, and we're saying if the directive name is foo, we don't care if it's not foo, because this is a rule for the foo directive. We basically say if the directive isn't on a field definition, because it could be applied onto an object, right, incorrectly. But once again, we don't care about it here. There's other rules for this. We're trying not to duplicate logic that's in other rules. Just return, ignore it if it's not on a field. Then I convert that horrible path array, directives number, or whatever it was, into just an object which contains like, you know, just definitions, number, field number, directives number as an object instead of an array. So it's just a bit nicer to use. Then we get the parent type definition. So you have to just roll with me on some of this because it's hacky talk code. Remember in our ancestor it started with a document, and then it was a list of all of the definitions. Well, the definitions in our path object refers to the second entry in that array. So document first, then the definitions. So we're getting number 1, which is those definitions, and then within that array, we are getting the particular definition we're interested in. So now we're on the object, which contains a field, which has the directive. So hacky, this is horrendous. And then we basically say, if that parent type definition is not an interface, throw an error. It can only be used on interface field definitions. So with that added, hey, it can only be used on interface field definitions. So we should go back and we should fix that, right? So where is our problem? Hey, this one's used on a type. That's bad. Let's get rid of that one. Let's run that validation again. And then we're back to 0 errors. This is good. And then let's do something else. Let's say we're going to add a new directive. And we're going to call it bar creatively. And we're going to say this one must be used on field definitions. But personally, I think bar is not much good without foo. I want to say that if you're using the bar directive, the foo directive must also be used in the same location. So I think we can do a rule for that. So we're going to go back into here. We're going to import our next rule, which is bar requires foo directive rule. This one's lovely. Instead of using the ancestors this time, we're using that parent thing, right? And if you remember correctly, the parent is the field. No, it's not the field definition. The parent is you have a single directive which you're validating, and the parent is the list of the directives in that location. So that's perfect. We've already got this nice reference point where we can look for different directives. So we're basically saying if the directive name is bar, if the parent exists, and it's an array, then if there isn't another directive here called foo, then we're just going to throw an error. Must be used with the directive foo. So now if I try to, for instance, add that onto here, where there is no foo, error. Directive bar must be used with directive foo. However, if I put it here, where it should be, and validate, encounter 0 validation errors. So many things. So that's basically all I had to talk about today. I think that fits pretty much within my 20-minute frame. Have a play with this. It's really kind of fun. And there's more validation to this. I just wanted to focus on that SDL side of it. But you've also got the whole request lifecycle validation as well. You can also jump into this too and do crazy validation stuff here. This demo is available. It's terrible code. I'd encourage you not to look at it. But if it's of interest to you, it's up on GitHub and you can take a look. That's all I have to say. I hope it wasn't too crazy.